Okay, radicals. So, radicals are, they all look like this. So radicals are that. They could have numbers here, so it could be 4, it could be 1,000, could really be whatever, okay? And there's different radicals we deal with. So we deal with square roots and cube roots and fourth roots and fifth roots, and it can go on forever, okay? So let's talk about like what some perfect squares are, what some perfect cubes are, what some perfect fourths are. So perfect squares, that would be like x squared, y squared, 1, 4, 9, 16. And so 1 is a perfect square because 1 squared equals 1. 4 is a perfect square because 2 squared equals 4. 3 squared equals 9. 4 squared equals 16. Hopefully you're getting the point now. And so on. Okay. Now perfect cubes, same idea. So it would be x cubed, y cubed, and then 1, 8, 27, 64. So that would be like 1 cubed equals 1. 2 cubed equals 8. 3 cubed equals 27. 4 cubed equals 64, and so on. Okay? And then fourths, that's like x to the fourth, y to the fourth, 1, 16, 81, 256, and so on. And I'll just explain it again. So 1 to the fourth is 1, 2 to the fourth is 16, 3 to the fourth is 81, yada, yada, yada. Okay? So we're going to get into simplifying radicals. And the easiest way to simplify radicals is to get it down to its prime factorization. Okay? So if we break this down, I know that 252 is the same as 2 times 126. Well, I can break down the 126. 126 is the same as 2 times 63. 63 is the same as 7 times 9. 7 is prime, 9's not, so 7 breaks down to 3 times 3. Okay? And now this is a square root. So anytime you don't have a number here, so there's no number there, you assume it's a 2. Okay? Which means that we need to have pairs in order to pull something out. So we have 2 2's and we have 2 3's. So that means I can pull out the 2, and that goes on the outside of the parentheses. I can also pull out the 3. And then those numbers multiply together. So 2 times 3, and that's 6 square roots of 7. Okay, let's do this one. So this one is a cube root, which means that I need to have groups of 3 in order to pull something out. So you always look at that number outside of the radical, and I will tell you what to pull out. If there's not a number, you assume it's a 2. So for this one, 128 is the same as 2 times 64. 64 is the same as 8 times 8. 8s, both those 8s can break down to 4 times 2 and 4 times 2. Then those 4s can break down further to 2 times 2 and 2 times 2. So 128 is really the same as 2 times 2 times 2 times 2 times 2 times 2 times 2. Okay. Now I have 3 2's there, so that's one group. 3 2's there, so that's another group. I can pull out that purple 2. I can pull out the blue one. Then I multiply all those numbers together. So 5 times 2 times 2 is 20. Then the 2 is on the inside still. Okay? Let's look at this one. So this is a fourth. So that means I need to have groups of 4. And I'm going to do this one using the factor tree. So I usually do these with factor trees. This is how, like, when we do them in classes, this is how I'm going to write them. So we're trying to look for 4 terms here. So that's 48 breaks down to 2 and 24. 24 breaks down to 2 and 12. 12 breaks down to 2 and 6. And 6 breaks down to 2 and 3. And then notice we're looking at the ends of the tree. So we're kind of thinking about like the fruit at the end of a tree. Okay, you only want the fruit. You don't really care about the branches. That you're not going to pick the branches. You're only going to pick the fruit off of it. Okay, so we have that group of 4 right there. Which means I can pull out that 2, and you have 2 times 2, and the 4th root of 3. 2 times 2 is 4, so that's 4 fourth roots of 3. Okay? I want you guys to do those examples. Let's look at this. So adding and subtracting. The first thing you should always do when adding and subtracting is simplify the radicals. anytime we work with radicals, the first thing you need to do is simplify the radicals. So we're going to simplify the 32. That's 2 times 16, which is 4 times 4. So we have that group of 4, so I can pull that out, and you get negative 20 square roots of 2, because then 4 multiplies to the 5. We're going to break down the 18 also, so 2 times 9, 3 times 3. You can pull out that 3, and you have 7 times 3, which is 21 square roots of 2. Now, square roots work the same as like variables. So if you had 3x plus 4y, you couldn't combine those, right? It works the same as if you had like 4 square roots of 3 plus 3 square roots of 2. You can't combine those because these are different, okay? But here they're the same. So if they're the same, you can combine them. So negative 20 square roots of 2 plus 21 square roots of 2 is 1 square root of 2, which is just the square root of 2. Okay, let's look at this one. So we're going to simplify first. Now, anytime there is a negative underneath a cube root, you can pull out that negative 1. That is super important to remember. Anytime there's a negative under a cube root, you can pull out the negative 1. Okay, so let's break down the 56. Well, that's negative 1 times negative 1 times negative 1 times 2 times 2 times 2 times 7. I'm just putting this right here to show you that you can pull out a negative 1. Because negative 1 times negative 1 is positive 1 times negative 1 is negative 1. Okay, now we're looking for groups of 3. So I have that group of 3 and that group. So I can pull out a negative 1, I can pull out a 2, and I'm left with negative 2 cube roots of 7. That has to multiply to the negative 3 that's already on the outside there, so that's going to be 6 cube roots of 7. We're going to do the same thing with 189. So that's 3 times 3 times 3 times 7 if you made the factor tree and found the prime factorization. Those 3 right there to make a group, so I can pull it out, so that's going to be 3 cube roots of 7. Now those are the same, so I can add those together and you get 9 cube roots of 7. Okay. Try those next examples. Let's look at this one. Same thing. I'm going to start by simplifying these. Okay, so the 18 breaks down to 2 times 3 times 3, which you can pull out the 3, so that's 3 square roots of 2. 20 breaks down to 2 square roots of 5. So that's going to be negative 3 square roots of 2, and then 2 times 2 square roots of 5. So that's negative 3 square roots of 2 times 4 square roots of 5. Now, when you multiply radicals, it's outside with outside, inside with inside. So that's going to be negative 3 times 4 is negative 12. 2 times 5 is 10. So that's going to be negative 12 square roots of 10. Okay. Check to see if you can simplify it. You can't simplify that one, so you just leave that. Okay, let's look at this one. So first we're going to simplify it. So for the 3 times x times y squared, that's 3 times x times y. So we can pull out a y. For the 15x cubed y, we have 3 times 5 times x times x times x times y. Well, I can pull out an x. So I have 7 times y square roots of 3x, and I have 3x square roots of 15xy. That's going to be 7y square root of 3x times 3x square root of 15xy. Now we multiply outsides with outsides, insides with insides. So that's going to be 21xy square root of 45x squared y. Break down that 45 and you get 5 times 3 times 3 times x times y. So you can pull out the 3, you can pull out the x. So that's 3x square roots of 5y. Multiply those together. So 21 times 3 is 63. X times x is x squared, and then we have the y. And the square root of 5y stays. Okay? Now this one, so anytime you see this, I would use distribution or the box. I'm just going to walk through that distribution, but I want you guys to use the box actually. So I'm going to draw this out with the box. So we have 5 minus square root of 2, and we have 7 square roots of 2 plus 1. So if we do 5 times 7 square roots of 2, 5 times 7 is 35. Square root of 2 just kind of stays. Negative times the negative square roots of 2 times 7 square roots of 2. That becomes negative 7 square roots of 4. 5 times 1 is 5. And then negative square roots of 2 times 1 is negative square roots of 2. Now this right here, we can simplify this. The square root of 4 is 2. So that's going to be negative 7 times 2, which is negative 14. Now we combine like terms. So we have our square roots. So that's going to be 35 square root of 2 minus square root of 2 is 34 square root of 2. 5 minus 14 is negative 9. Okay, you can see we got the same thing there. So you can use distribution if you want. You could also use the box. I like the box a little more. But okay. Yeah, so remember if you have a squared like this, that just means you have 2 of them. Okay, you do it the same way. Dividing radicals, so always simplify first. So we're going to start with simplifying the 480. So that's 2 times 2 times 2 times 2 times 2 times 3 times 5. So I can pull out the purple 2, can pull out the blue 2. So that's 4. Square roots of 2 times 3 times 5 is 30. So that's going to be 6 times 4 square roots of 30 over 2 square roots of 6. Well, 6 times 4 is 24 square roots of 30 over 2 square roots of 6. 24 over 2 reduces to 12 over 1, so that's 12 square roots of 30 over 6. Now we can multiply top and bottom by the denominator, by the radical in the denominator. It just has to be the radical. Okay, so we're going to multiply top by square root of 6 and bottom by square root of 6. That's going to be 12 square root of 180 over 36, square root of 36. Anytime you multiply a square root by an identical square root, you're left with whatever's underneath. So that bottom, the square root of 36 is just 6. And then 12 divided by 6 is 2, so that's 2 square roots of 180. We can break down that 180 to 2 times 2 times 3 times 3 times 5. Pull out the purple 2, pull out the blue 3, and you get 2 times 3, which is 6 square roots of 5. So that's going to be 2 times 6 square roots of 5, which is 12 square roots of 5. This one, simplify first. So here we can pull out a negative 1. Anytime you have a negative under a cube root, pull out a negative. And then 2 times 2 times 2 times 2 times 2 is 32. So we can pull out a negative 1 and a 2. So that's going to be negative 2 cube roots of 4. So we have 7 times negative 2 cube roots of 4 over 2 cube roots of 4. Well, 7 times negative 2. Here, let's do this step by step. So 7 times negative 2 is negative 14. Then the cube roots of 4 over 2 cube roots of 4. Well, those cancel, and you're left with negative 14 over 2, which is negative 7. Okay. This one, so if the whole thing's under a cube root, let's simplify inside there first. So 288 divided by 2 is 144. If you have 7 j's on top and 2 on bottom, that means 2 of those cancel. I think some of you guys are struggling with this, so I'm going to write it out. So if we have 7 j's on top, 6, 7, and we have 2 on bottom. Well, that means that these 2 are going to cancel with those 2, and I'm left with 5 up top, which is where that j to the 5th comes from. You can do it similarly with the k's. So if we have 3k or 4 k's and then 1 on bottom, one of those cancels. You're left with 3 right there. Okay. Now we can just simplify this. So 144 is 2 times 2 times 2 times 2 times 3 times 3. I wrote out all those j's and all the k's. And then I'm looking for groups of 3. So I have 3 2's, I have 3 j's, and I have 3 k's. So I can pull out the 2jk. I'm left with 2 times 3 times 3 times j times j. Well, 2 times 3 is 6, times 3 is 18. So that's 18j squared on the inside. Cool? Try those next examples. Sorry, this is kind of a lot. We're almost done, I promise. So now when we switch in between exponential and radical, this is very important. So all you need to remember is the top number goes on the inside, the bottom number goes on the outside. So if we have p to the 9/2, top number is on the inside, bottom number is on the outside. So that's going to be the square root of p to the 9th, which you can just write square root without the number on the outside. Okay, this one. I want to write one more. So say you have like z to the 7/10. Top number's on the inside, bottom number's on the outside. So that's going to be the 10th root of z to the 7th. If you had 4y to the 9/4 power, that's going to be bottom number's on the outside, top number's on the inside. So that's going to be the 4th root of 4y to the 9th power. Okay. This one, so they're all under 3. And so let's just change this to radical form right here. So that's going to be the cube root of 27 to the 1st power. Because remember, bottom number goes on the outside, top number goes on the inside. And then the cube root of r to the 17th, and the cube root of s to the 8th. We can break this down further. So the 27, if you take the cube root of 27, 27 is the same as 3 times 9, which is 3 times 3, which is where that 3 comes from. R to the 17th can be broken into r cubed times r cubed times r cubed, 3, 6, 9, 12, 15, 16, 17. Okay, so we have 1, 2, 3, 4, 5 r cubes there, so this is where the r to the 5th comes from. And then our s squared, that can be broken into s cubed, and then s times s. That's where those two come from right there. Okay, finish by multiplying it out. So that's going to be 3r to the 5th s squared, cube root of r squared s squared. Okay, this one we need to change it into radical form. So the k is the only thing being raised to the 3rd power there. Unless it's in parentheses, it's just the k. So this is going to be 5k to the 3rd power, all to the 1/4 power. Then we can break this up even further, so that's going to be 5 to the 1/4, k to the 3/4. Okay? Now this one, see the difference between the two? This one is just going to be 4y to the 3/2 power. Inside number goes on the top, bottom number goes on the outside. Or outside number goes on the bottom. Okay, we're saving the rest. Try to do them if you want. Yeah, sorry for making this long. I promise videos aren't crazy long the whole year. Okay, you guys are the best. Goodbye.